Hi everyone. So some parts of the real numbers we have studied. The next part we are going to continue. Revisiting irrational numbers. Already we have defined rational numbers and irrational numbers. So here rational numbers are denoted by the symbol Q. Just you can define which is a number which is in the form of P by Q, such that P and Q are integers and Q is not equal to 0. These are said to be rational numbers. So how we can identify the irrational numbers? So how we can tell which cannot be put in the form of P by Q? Where the numbers which can put in the form of P by Q are said to be rational numbers. But definition tells about irrational numbers that is denoted by Q dash. So how we can identify which cannot be put in the form of P by Q? Is it? So here also P and Q are integers. We can tell also the Q union Q dash. Together the formula is set of reals. Set of real numbers. Already we have so many things we have learned. The theorems also, fundamental theorem, division lemma, and now how we are going to say the number is irrational number. Just an example you can take and you will see that. So now, just for example, root 2 and irrationals are told that which cannot be put in the form of P by Q. Which cannot be put in the form of P by Q means which are in different way. So what is the square root of 2? What is the square root of 2? So square root of 2, just you can see that by long division method. By long division method. You can understand that. How can we get the square root of 2? What was we studied? To find the square root of 2. So now here 1 square is 1. That is method to find the square root by long division method. Yes. Which are non-perfect square numbers. Just you can tell here, root 2, root 3, root 5 are said to be non-perfect square numbers. Another time, how to get square root of that number. It's okay. So now, that is 2 minus 1 is 1. So decimal comes. So these two zeros. So now that 1 is added here, which is equal to 2. So the number which we are going to take in front of that 2, from that we are going to multiply. That is 24 fours. 24 fours. 4 fours 16. That is 9. So again these two zeros, we are getting that 4 is added. So now 2 8 is there, 400 is there. 2 8 by taking 1 2 3 like that. 281 ones are 282 twos are 282 becomes more than 400. So 281 ones are 281. Yes, again these two zeros, that one is again added here. 282. The number we are going to take. It means that square root of 2 is equal to 1.4143 like that. Again, just one of these steps I have told you. So when you are taking in this way, square root of 2 is equal to 1.4143, whatever it is. which cannot stop. It means your point is non-terminating. Yes, non-terminating. Also, sometimes, just for example, 2 by 3 is equal to 2 by 3 is equal to 3, 0.666. It's said to be recurring, repeating. When there are repeating decimals, okay, they are rationals. But here, non-terminating, non-repeating. It means repeating not also possible. So, such numbers are called irrational numbers. So, non-terminating, non-repeating means non-recurring numbers are said to be a recurring decimal. So, square root of 2 is also said to be root 2 is irrational. Root 2 is irrational. So, rational numbers are told q is in the form of p by q. P by q. But here, p by q is p and q are integers, q is not equal to 0. But here, q, when it is divisible p and recurrent, may be terminating or recurring. But in this case, non-terminating, non-recurring. So, this cannot be put in the form of p by q. Root 2 cannot be put in the form of p by q. So, root 2 is called irrational number. Like that, root 3, root 5. So, what we can tell that is root of when p is prime number, and that will be said to be irrational number. Just for example, what about root 4? 4 is not a prime number, so square root of 4 is 2. So, in this case, when p is prime number, square root of that prime number is said to be a irrational number. This is practically what we are saying. So, 1.41 like that. Whatever the number of steps you are going, it not stops. It means non-terminating, and also sometimes it is not repeating also. So, such numbers are called irrational numbers. So, they cannot be put in the form of p by q. So, which are not rational, they are said to be irrational. Is it? So then, how we can? This is theoretically, practically we have proved, but theoretically I am going to prove. Before that, there will be a theorem. There will be a theorem. What is that? Before going to prove that root 2 is irrational, then let p is a prime number. P is a prime number. Yes, a is positive integer. A is positive integer. Yes, if p divides a square, then p divides a also. This is a very important theorem related to prove root 2 is irrational. So now p is a prime number. P is a prime number. A is positive integer. If p divides a square, then p divides a also. P divides a also. This is theoretically theorem you can prove, but not necessary to prove the theorem, but generally you want to know that. Yes, a is positive integer. What is a square? Just for example, 6 is positive integer. So 6 square is 36. 6 square is 36. P is prime. P is prime. Yes? Understand that thing? Yes? So 2 is prime number. 2 is prime number. Is it 2 divides 36? Yes, 2 divides 36, which is 18. And 2 also divides 6, which is 3. Understand? Here, answer is not important. Answer is not important here. The thing is, every case, yes, 6 is a positive integer. 6 square is 36. P is a prime. I am taking 2 as a prime number. So, if 2 divides 36, it means 6 square, then P divides 6 also. So, when you are writing that, if 2 is a prime number, 2 divides 36, which means 6 square. 2 divides 36 means 6 square. Then 2 divides 6 also. This is very important theorem and is true for all the numbers when P is a prime. P is a prime. A is positive integer. So symbolically what we can write? P divides A square. P divides A square. It implies P divides A also. This is symbolically we can tell. So this is very important theorem. Is it? So to prove root 2 is irrational, this is a very important theorem we are going to use. Yes, very important. Another one example. Yes, 6 square 36 is, that is 3 divides 36, it means 6 square. 3 is a prime number. Yes, 3 divides 6 also. If 3 divides 6 square, then 3 divides A also. Very important point here. Understanding? So many examples you can take. Yes, just for example, 5 divides is 625. 5 divides 625 means 25 square. Then 5 divides 25 also. Understanding? 5 is a prime number. 5 divides 25 square. So 5 divides 25. Very simple theorem. Easily understandable is when P is a prime number, A is a positive integer. Then what? If P divides A square, then P divides A. So many examples you can take. 6 different examples. 7. Yes. 7 divides. That is if 7 divides 7 square means 49. Then 7 divides 7 also. 7 is a prime number. Is it? Yes. Very careful about that. Square. P is a prime number. A is a positive integer. What it is? If P divides A square, then P divides A. Very important. Once again, so that is very important. Okay. Yes, just you can write in the form of sentence, in the form of theorem. Yes, like P is a prime number. Yes, if and A is positive integer. A is positive integer. If P divides A square, then P divides A. Very important. That P is a prime, A is a positive integer. If P divides A square, P divides A also. So now, prove that some examples. Prove that root irrational. Root 2 is irrational. Yes, practically we know that the square root of 2 is 1.4143, which will not terminate, which will not repeating. By that you can understand it is a irrational number. So theoretically I am going to prove it. So here one method we are using, that is said to be contradiction method. What it is? Contradiction method. What is contradiction method? To contradict, to the contrary, means that first we are telling that root 2 is a rational number, then by the help of the steps, by the help of theorem, what the contradictor already taken as a rational number, it is wrong, so then we can take it is irrational number. Yes, understand that is contradiction method means first we are telling that as it is, then by help of some rules we are telling what is our assumption that is wrong, then which is correct. That is said to be contradiction method. Is it? So now first one is to take that root 2 is rational number. Yes. So yes, let us assume to the contrary, root 2 is a rational number. Root 2 is a rational number. Yes, contradiction. We are assuming root 2 is a rational number. Okay, so root 2 is a rational number means therefore a rational number which you can put in the form of p by q. So that is root 2 is equal to a by b. So rational number, take that. Root 2 is rational number. So a and b, where a and b are co-prime. Very careful this. Co-prime. What are co-primes? Whose HCF is 1. So just for example, 6 by 8 is a rational number, but it is not in simplified form. So what it is? 3 by 4. Yes, this is a 3 and 4 are co-prime. At that time only we can call them a rational number. So root 2 equal to a by q was considered. We are just assuming that rational number. So root 2 equal to a by b, where a and b are positive integers or integers and co-prime. That is the definition of rational numbers. P by q, where p and q are integers and q is not equal to 0. So co-prime. Understanding? So whose HCF is 1. Yes. So now that is HCF of A and B is 1. At that time we are going to use co-prime. Yes. Okay. So now by simplification, b into root 2 is equal to a. Simple method, b root 2 equal to a. Squaring both sides. On squaring both sides, 2b square. Root 2 square is 2. b means b square. 2b square equal to a square. 2b square equal to a square. What it tells? Just you can give the name for this one. What you can tell? 2b square equal to a square means b square equal to what? A square by 2. It means 2 divides a square. 2 divides a square. It implies that 2 divides a square. 2 divides a square. 2 is a prime number. A is a positive integer. Yes, 2 divides a square. Theorem states that 2 divides 2 divides A also. Theorem which we have proved that theorem. If P is a prime number, dividing A square, there is a positive integer, then 2 divides P divides A also. It means 2 is the one of the factor of A. 2 is the one of the factor of A. Therefore, A is equal to 2C for some constant integer. Yes, for some integer C. Yes, 2 divides A means A must be is equal to 2 times some integer. So, substitute this. Put A is equal to 2C in 1. Yes. So, what happens here? 2B square equal to A equal to 2C bracket square. Yes. So, 2B square equal to 4C square. Yes. 2 ones are 2, 2s are. So, means 2C square equal to B square. 2C square equal to B square. What it means? C square equal to B square by 2. C square equal to B square by 2. It implies that 2 divides B square. 2 divides B square. Again, theorem tells that if 2 is a prime number, divides B square. 2 divides B also. 2 divides B also. Understanding, I think? 2 is a prime number. B is any positive integer. If 2 divides B square, 2 divides B also. So what we can conclude? 2 is factor of A also. 2 is the factor of B also. Here our assumption is A and B are co-prime. At that time it is rational. But according to the step, according to theorem, A and B are having other than 1. The factors are there. 2 is also factor. Who just said is 1, but here 2. 2 divides A also, 2 divides B. It means they are not co-prime. They are not co-prime. They are not co-prime means which our assumption root equal to A by B is wrong. Which is wrong? Which is taken as rational. Rational assumption is rational, which is wrong. It means it is irrational. Yes. So our assumption is so A and B are not co-prime. Not co-prime. Therefore, our assumption root 2 is rational, is wrong. Yes. Here we are not co-prime, so our assumption which we have taken root 2 is rational is wrong. Therefore, root 2 is irrational. Root 2 is irrational. By the help of theorem. Once again, the steps. What is that contradiction method? I think you understood. Yes. Let us assume to the contrary, root 2 is a rational number. So root 2 is a rational number means we are taking the list root 2 equal to A by B, where A and B are co-prime. It means HCF is 1. Co-prime. Yes, by simplification, B root 2 equal to A. Simplification. On squaring, root is equal to A square. It tells that 2 divides A square. 2 divides A square. By the theorem, 2 divides A also. It means 2 is the one of the factor of A. So let us take that A is equal to 2C for some integer, whatever it is. So that is substituting in first one. So we are getting that 2c square equal to b square. So 2 divides b square. Theorem. 2 divides b square, 2 divides b also. It means a and b are not co-prime. When they are co-prime, at that time only it is a rational. When a and b are not co-prime, so what assumption or assumpted, that is root 2 is rational, so it is wrong. So we can tell root 2 is irrational. This is said to be contradiction method. So root 2 is irrational. Understand? Sum means 2 plus root 2. Yes, what is 2? 2 is rational. 2 is rational. Root 2 is irrational. Sum of rational and irrational is irrational. Very careful about. Sum of rational and irrational is irrational, and difference is also irrational. Yes, and root 2 into root 3. Root 2 is irrational. Root 3 is irrational. Root 2 into root 3 equal to, that is root 6, is also irrational. Product of two irrationals is irrational. Yes, sometimes, see, totally irrational. So now sometimes 2 plus root 3 or 3 plus root 2 into 3 minus root 2. What happens? It is irrational number. It is irrational number. So a plus b, a minus b equal to a square minus b square. B square minus root 2 bracket square equal to 9 minus 2 equal to 7 is rational. See. This is said to be rationalization. One at the time 3 plus root 2, 3 minus root 2 are the irrationals. So at the time 3 plus root 2 is said to be a rationalizing factor of 3 minus root 2. 3 minus root 2 is called rationalizing factor of 3 plus root 2. See here. Here some approach of monomials like that. Let's add one example. 2 root 2 into root 2 or root 3. Yes, which is equal to 2 root 6 is irrational. So, when we talk about sum or difference, or of two rationals plus irrationals, they are rational or irrational. By the help of addition, we can understand that it is rational and irrational. Okay. And also, root 2 by root 3 quotient is again irrational. Is irrational again. Some are there. Methods are there. How to rationalize the denominator, that we will study next class. Okay. So sum or difference of rational irrational is irrational. And what about this? Root 2 plus root 3 is as it is. No need to add here, not possible to add. So sum of two irrationals is irrational. Difference of two irrationals is irrational. Rational and irrational is irrational. Rational and irrational is irrational. Product may be. So both are rational, irrational. Here, one is said we are studying higher classes. Okay, this is rational. irrational. 2 root 3 is irrational. Yes. Let us assume that. Let us assume the contrary. The contrary. 2 root 3 is rational. Consider. Yes. Therefore, this rational means 2 root 3 equal to a by b, where a and b are co-prime. Very important this is. Let's say co-prime is 1. Okay. So, therefore, simplification gives that root 3 equal to a by 2b. Yes, root 3 equal to a by 2b. A and b are integers. A and b are integers. So, a by 2b is rational. A and b are integers. A by b is rational. A by 2b is also rational. Yes. So, a by 2b is rational. But we know that root 3 is root 2, root 3, root 5, root 7, root 11, root 13, root 12, root 14, 15 like that. They are all irrational. A by 2b is rational, but we know that root 3 is irrational. So, is it possible irrational is equal to rational? Not possible. Is it? So root 3 is 3 root 3, 2 root 3 is irrational. Understand? Yes. Here, to the concept not necessary, but we already know that root 3. So, a by 2b is a rational number, but we know that root 3 is irrational. Irrational is not equal to rational. Yes. So, 2 root 3 is irrational. In this way, we are going to prove that. Let's prove that 2 plus root 2 is irrational. See now, sum of rational and irrational is rational. So we are going to prove. Yes, let us assume to the contrary 2 plus root 2 is rational. We are assuming that it is rational. Therefore, 2 plus root 2 is equal to a by b, where a and b are co-prime. Means integers. A and b are integers. Co-prime, and now you know that already b is not equal to 0. Right? Therefore, simplification gives that root 2 equal to a by b minus 2. Simplification, which equals to a minus 2 into b divided by b. Here a and b are integers. A and b are integers. By this you can understand that. Yes. So a minus 2b by b is rational. Yes. but we know that, here RHS is rational because A and B are integers. Whatever the value we substitute, it comes in the form of integer, in the form of rational. So, but we know that, what we know? We know that root 2 is irrational. Root 2 is irrational. So whatever we can add to the rational number, irrational number, it is irrational. Root 2 is irrational. Therefore, 2 plus root 2 is irrational. Already we proved that root 2 is irrational. So we can understand that 2 plus root 2 is irrational. In this way, we are going to prove how the irrational numbers are. Is it? So this is the part. Yes. Let's take some examples. Prove that root 5 is irrational. 3 plus 2 root 5 is irrational. 7 root 5 is irrational. 3 root 5 minus 8 is irrational. Root 3 plus root 5 is irrational. 2 root 3 by 5 is irrational. So try to once again understand the contradiction method. Try to do this in the same steps. Okay? We'll see next part in the next class.